The final view, what we do have also in VistaSoft, is the MPR view. Very important for diagnosing CBCT images. The MPR view, multiplanar reconstructed view, is an arrangement of an axial view, a coronal view, which is the blue plane. So the coronal plane you see here, if I move my rendering here, and I'm moving this blue coronal view, so we see which plane will be aligned as soon as I move here. And I can do the same here in my coronal view of my MPR in this blue section here. And again, the same, the green plane is my sagittal view. As soon as I operate here, I can navigate with this one here. MPR is very important for screening all the areas, because you are the one creating the CBCT scan. So you have the responsibility to diagnose the CBCT scan, not only in the area where the patient probably has some issues and the patient is coming to the clinic and talking to you, but as soon as you create a CBCT scan, you are responsible for all the diagnosable area of the CBCT scan, and you really have to go through all the scan in all the planes, and if there are some suspicious areas, you can mark them in the software, you can make some comments for you yourself. For example, if you see here with the right mouse button, you can actually pan the image, then you can zoom in more. And if you see, for example, here some issues in this area, in the root area of this molar here, so there is something suspicious. What also is always possible, as soon as you provide or create a double click in our views, the crosshair will directly jump to this specific area and to this specific slice. And that means, for example, I did here a double click, and also in my coronal view, I am now in this region where I actually sliced in by double clicking here in this layer of my CBCT scan. And we see this also in the visualization here of our rendering. And of course, also in the sagittal view. Okay, now one important thing to understand is also here in our toolbar at the right-hand side, functionalities to what you probably need to diagnose images more specifical, or options to change, for example, a layer thickness. Then we do have the option to create a nerve canal proposal, what I will do very soon. I will show you here the functionalities in our volume rendering, then which kind of visualizations we do have here. I would like to explain you the histogram function. Then, as I said earlier already, this new UHD filter, how it looks like without and with this UHD filter. And then the options down there for doing measurements, drawings, and also now this text option to have annotations in text form in our images, that you can that you have actually the function, the option to make comments for you yourself, or if you share images, then the recipient of the image will also see these comments and annotations. Okay, I will start here with the slider that which is available for the layer thickness. You know, there is always a specific and individual voxel size for a CBCT scan, and with a VistaVox, and if it's a full volume for a VistaVox, when I'm talking about a full volume, is what we see here in this scan. So this is all the dentures, the lower jaw, the upper jaw, even the molars, and the the arches going there up to the joints of the patient. So this scan will be performed by a voxel size of 200 microns with a VistaVox. This is our default. For the 5x5 CBCT scans, we have the options to have a higher resolution. That means then we scan by default by 120 microns, which is 0.12 millimeter. Or in the setting of 80 microns, we will have a resolution of 80 microns, which is 0.08. To turn my sagittal plane to an alignment along the sagittal view. What did I do? You saw I did a double click first in the area near this implant or this tooth, molar tooth here. The double click alone will center the crosshair to this one. And then I showed you earlier, in these areas of the planes, there are some dotted areas. And as soon as you click your mouse there, you can align the planes along, for example, this patient's jaw. And if you zoom in here, you will see here these structures more clear. So you saw now, for example, when I used here to align the sagittal plane, of course, in the same time, also the coronal plane will be aligned because they belong to each other. And here, if, for example, you wanted to align also the axial plane, the red one, so then you can do it also, of course, in this dotted area. So you see here also in the rendering, as soon as you touch here the alignment of this plane, then you will see it also in our rendered image. Now, for example, if you're interested to see more details in the structures of this implant in the patient's lower jaw, I just focus on this one. I double click here, and you already can see that the center of my double click jumped directly to this implant. The alignment of the implant here in the coronal view is not yet following the alignment of the implant itself, but it's easy to do it now. So I can actually align along this plane of this implant. And even now, if I zoom in and move my mouse along this area here, I can also align my sagittal view now along this implant. And for example, if I want to do now a measurement, then the measurement will be really very accurate because I aligned now my CBCT volume exactly on the level where I wanted to perform a measurement. And that's always important to understand. As long as you are doing a measurement in the 3D image, you have to think of what you wanted to measure and in which orientation and which alignment you wanted to measure. And that's why I wanted to let you see this kind of alignment of all those planes. And then it makes sense to use, for example, here, our measurement tool. You click here, and as soon as, for example, we click here in the area of this implant from here to here, down there, then we see actually, I guess this is an implant of maybe 12 or 12.5 millimeters from a manufacturer. And this measurement is now very accurate by reason we aligned the CBCT volume first along this area where we wanted to see it.